All right, so I just asked you to group together your bowling ball demonstrations, and I need you to be able to tell me how you grouped them and then justify why you grouped them that way. Hello? I do. Okay, I'll let him know. Thank you. Bye. Aaron, your mom is here. Okay, so I just want you to tell me how you grouped them, and then I want you to justify why you grouped them that way. Are you ready?
I know.
Oh. Who should I pick to go first?
I'll go if you want to go. Bring it.
Well, here. Caleb, Flusher. So go ahead and tell us how you grouped them as a group, and then why you grouped them that way.
We grouped them up with the ball already moving and the ball staying still, because when the ball's moving, well, yeah, it was kind of.
It's kind of explanatory,
Yeah.
right? Okay. So, just at the start?
Yeah.
Okay, so when the demonstration started, you have one group where the ball was already moving and one group where it was not moving. Did I understand you right?
Yeah.
Okay. All right. Leah, how about you guys?
We grouped them by, like, at the start when the broom was touching the ball and then it was not touching the ball.
Okay, so you had two groups. One group was where the broom was touching the ball at the beginning, and one group where the broom was not touching the ball at the beginning. Is that correct? All right. Johnny, you're in that same group, right? Caleb.
So we kind of did the same thing as Caleb, how the ball was in motion, or when it wasn't in motion.
Okay. So you just had two groups as well? All right. Brooke. Oh, you guys were in Taylor's group. Never mind. Sorry. Gage. Cooper.
So we had the same thing as Caleb, but we marked which ones.
Which ones what?
So like 4, 6, 7, 8 were in motion, and 1, 2, 3, 5 were
Okay.
at the beginning.
So you grouped them by which ones were in motion at the beginning and which ones were not.
Yeah.
Okay. Aaron just left. Walker, you guys did the same thing. Draven, how about you guys? Still trying to decide? Alright. It's hard when we do this in groups because I feel like I'm going through the groups. Ty, how about you guys? How'd you guys group them?
This is how we grouped them. So in the beginning, you did it where you didn't make the ball move. You know, it was stationary. And then with the next few, you would use the broom to make the ball move, like
Okay.
tap it. Then there were some times where you take the broom and actually drag the ball, like push against the ball and let it drag against the broom. And then towards the end, you had two brooms. And you were using that to either keep the ball stationary or to move it around.
Okay.
When the ball was moving in the beginning, then we did it.
Okay. So did anybody group it based on how the ball moved?
Like directions of possible?
Could be direction, or it could be
Speed.
how fast. Nobody did that? Would that be an interesting way to think about it?
Yeah.
Okay. So what are we trying to get at here? Anybody have any idea? Okay.
Maybe a way to group things based on what we saw.
Yeah, well, I mean, honestly, scientists, when they make an observation, the first thing they do is they try to compare it to something they already know. And that often happens, they're looking for similarities and differences in their observations, and then after they find those similarities and differences, then they start to try and compare it to things that we already know about. And from that, then they try to say, well, if it behaves this way here, and we know about that, then it's probably gonna behave similarly here, and then you start to have an opportunity to experiment with different things. So that's how science works. But with this specific set of demonstrations, what do you think we're trying to get at as far as a physics concept is concerned? Anybody know? It's a word that starts with F. Not friction, but friction is one of them. Forces. This unit that we're going to learn about is about forces. So, does anybody know the scientific definition of a force? All right. So I don't give a lot of notes, but I am going to write some things on the board, and I would encourage you to maybe write some of these things down. So are you ready for the science definition? Almost?
There.
It's a lot of writing, so I hope you did your finger stretches.
I didn't.
You didn't?
No, Lord.
Go ahead, take a minute, work it out a little bit. You ready?
Bruh.
Super high technical definition right there.
Can you explain it? No, I'm just kidding.
Well, how many of you have siblings?
Sadly.
That's how I'm gonna explain it.
I shouldn't. Dude, you thought that was way too funny, Joe. You have no clue, bro.
All right, so a force is just a push or a pull. A force is just a push or a pull. And, I mean, that's about as sciencey as it gets.
Oh, sweet card. The one time I get my green card.
Oh.
All right, so
It's okay.
we have two categories of forces. Does anybody know what those categories are?
Fast and slow.
Fast and slow. We actually don't talk about rate with forces. You're a little ahead
Oh,
of the
she
game
said
here.
horses. I thought she said
Because
horses.
we're gonna talk about fast and slow here now. Not too long from now, okay? Does anybody know what the categories for forces are?
No, but this thing is that there's
Guys, magnetic is a kind of force, just like friction is a kind of force. But the categories of force are contact and non-contact. Contact and non-contact. So what does it mean to be in contact? Touching. Forces that are contact forces are forces that come from two or more objects touching each other. So anytime we have objects that are touching each other, there is a force between them. Okay? Sometimes you can have a bunch of different things in contact with each other. You have a bunch of different forces represented there. So for example, if we look back here at Walker's desk, the table that he's sitting at, that specific table, how many forces are acting on that table?
Two.
Okay, so his elbows. Is there anything else in contact with that table?
The Chromebook.
The Chromebook, the floor, his notebook, the water bottle. There's a lot of forces going on there. All of those forces are coming from contact. Those are contact forces. Anything that's touching is gonna generate a contact force. Alright? So, what does non-contact mean?
Not touching.
Not touching. What kind of forces are not touching?
Gravity.
Ooh, gravity.
About
Say the G
wind,
word.
about wind, like,
Let's talk about that one just here in a moment. Let's talk about gravity first. That's a good one. Thank you for bringing that up. It didn't get brought up in my other class. I was really hoping it would. So, gravity. What is gravity?
force that keeps you
on down.
Okay, so a force that pulls down, right? Is
Yeah.
that what you said? Or the force that keeps you on the earth. Anything else?
Creates an atmosphere.
Okay.
And
It has no physical appearance that keeps things.
Gravity is such a bad word to use. But let me tell you why. Because when we talk about gravity, there are lots of different ways that people describe gravity. It's a word that's got a lot of strings attached to it. So I'm gonna outlaw the word gravity. I'm gonna outlaw the word gravity because technically the definition of gravity has to do with masses and distance between those masses. And yes, there is a gravitational force that keeps us stuck on the earth. And there is a gravitational force that it comes from the earth and it's really important to us because it keeps our atmosphere here. But what is generating that gravitational force?
magnetic something, shape.
It's the earth. The earth is what's generating that gravitational force. So we're going to refer to what you guys think of as the gravity force. We're going to refer to that as the force of the earth. Because that is specifically what's keeping us stuck to the surface of the earth, and that is specifically what keeps our atmosphere as the outside layer of the earth. Okay? So we're going to refer to that as the force of the earth. Other non-contact forces, Audrey, what did you tell me, the most recent one? Magnetic. Have you guys ever played with magnets?
Yeah, all the time.
Yeah? So when they get close to each other, do they have to be touching before you start to feel them pulling closer to each other?
No.
No. What about if you flip it around and you try to push them together? Can you feel them pushing apart without them touching each other?
Mm-hmm.
Those are non-contact forces. Another name for these are action at a distance forces or field forces. These are forces that don't have to be touching in order to act on an object. The only one that we're really going to encounter is the force of the earth. That's the only non-contact force that we're going to have to account for in everything that we do in this class. Do you have any questions about those? So let's go back to Walker's table that he's sitting at. And you guys told me that there's a lot of forces there acting, right? How do we account, how do we keep track of all the forces that are acting on that table? Does anybody know? We have to draw something.
Oh, don't say diagram.
A diagram? What kind of diagram?
Oh, it is. I'm not sure what
Okay.
kind, all I know is it is.
A force diagram. Have you guys drawn force diagrams in the past?
No,
No? No?
just don't like diagrams.
Well, I just want you to give it a try. We're gonna see if we can, I need to see where we're at as far as force diagrams are concerned, because I know that in middle school science, a lot of times Mrs. Lentz will teach forces. So I just wanna see what we can do, okay? So can you all see my file folders here?
Yeah.
All right, so there's a dark blue one. Letters. We're gonna refer to this one as teal. It's not really teal,
Baby
but
blue.
teal. And then I have my rainbow folder. And I want you to draw the force diagram for the teal one. Draw the force diagram for the teal folder.
Wait.
On your little green slip. of paper. Okay, then I'm gonna collect them, that's not what I wanted. I'm gonna collect them. I'm gonna give you 3 minutes to draw whatever you think a forest diagram looks like. And I'm going to collect them from you. We're gonna collect them from you. When you have them done, hold up your hand, but really take some time to try and draw it nicely. And then I want your names on them.
I don't even remember what diagram is.
It's okay, just do what you can, alright? Ready? Go.
I never went over when.
Hmm?
I never went over when and stuff.
Oh, good point. Remind me of that when we're done.
Okay.
Yeah. See, I forget these all the time.
Another question.
Yeah.
Do I have enough time to use the restroom, or do you want me to wait?
You can go ahead. We'll probably start talking about wind or air, because I completely forgot about that. So if you just go quickly.
Miss you. See you.
And this has,
I don't think she heard you.
She's leaving, she's leaving.
Yeah, she got doctor's appointment.
yeah, she's straight bowling.
Alright guys, if you have yours done, you still have some time, but if you have yours done, please hold it up and I'll come around and grab it.
Oh, yeah, I need my name on it. don't I?
Yes, please put your name on it.
Put on the back.
Yeah.
Oh, I almost forgot my ass. Here's Keith's.
Thank you.
Got this right, I'm just scribbling. This right, I'm straight. I'm just scribbling.
Overachiever, huh?
I didn't know, cause I came on and I was like, I remember this, then I was like, I don't know if it's right.
How do you want to,
That's all right.
Finger. Breathe. No, finger. What was that? I don't even know, I turned into like.
Time's up, so I'm gonna ask you to finish up if you're not done. And we're going to talk about it.
That's a long 3 minutes and a long time.
Yeah.
3 minutes, not long.
Mom's in Indiana right now, so. That's what I said, I was like, come on, man, I need some money for it. I'm a hungry boy.
Stop fumbling up her papers.
That's what we did, bro.
You can give it. I don't want it.
See what you did?
Alright.
Just people set up.
Wow.
Literally.
We're gonna pick this up.
I wouldn't do that.
I'm not saying something.
She gets it after this test.
You can see it, can't you? Thank you. Alright, so, I absolutely did not anticipate that you guys knew how to draw forest diagrams. That's okay, I just need to check. The other class period told me that they had before. And they're your same classmates. Okay, so, I just had to check so that I know where we need to start. Anyway, so there you go. Not one of these is a force diagram. So that's okay. That's absolutely okay. I saw the same thing in the last class, but they told me that they had drawn them before. So that's why I had you guys just try it. Yeah. So that's all right, because I'm going to show you how we do it.
I have an interesting fact. You
That's
don't
the
remember
3 minutes
50
I'm never
things
gonna
about
get back
that.
into either the longest 3 minutes of my
Yeah,
life.
you'll be fine. You're
Hey,
fine.
we didn't do it right.
Okay.
No, we did it right.
So before I show you how we're going to draw force diagrams, what I do want to talk about though is this idea of wind or air. Because wind is a mass movement in one direction of air, but air are actually tiny little particles. They're made up of matter. And in order for us to feel air pressure, those particles are going to hit us. So that is actually a contact force. Okay? Air and wind, they are contact forces. But wind is a contact force. Air doesn't really exhibit a force, a net force. And we'll talk a little bit more about that later. But for right now, what I want to focus on, I want to focus on drawing force diagrams correctly. So let's go ahead as a class, and we're going to draw a force diagram for this teal folder. And I would encourage you to write down some notes. I don't know how you've been asked to write down notes in the past, but I'm not asking you to write down just what I write on the board, right? I write down some things on the board, but we discuss them, and when we talk about them, some important information comes out. I would encourage you to write down that important information as well, because that's really the valuable stuff. You should never write anything down unless you understand it, okay? All right, so let's draw a force diagram for this teal folder. Now, this teal folder, it's kind of a flat rectangle. Would you agree with that?
Yeah.
So some people would tell you to just draw the folder up here. That's not how physicists do it. When physicists draw a force diagram, they're drawing it for what's called the center of mass of the object. And the center of mass is a center point where if you, you gotta find the middle, just based on the mass of the object. So if we work our way from all the corners of that folder, we're going to get to a point where where we're in sort of the middle part of the folder, and that represents the center of mass. But it's a center point. So when we draw a force diagram, we're going to start with a dot that represents our object of interest. Gage.
So, are you saying that we have to first describe what it looks like to determine?
No, we're always going to start with a dot, and we're going to assume that that's the center of mass of that object. And then we're going to put all of our forces on this dot, but our forces have to go on in a specific way. Not in order, but a specific way. All of our forces are going to be represented by arrows. And all of those arrows must point away from the dot. So we're never going to have a tip of the arrow towards the dot. It's always going to be pointing in a direction away from it. And I forget what I was going to say. Oh, the arrow has to point in the direction that that object is feeling the force. Okay, I'm going to say that one more time. The arrow is always going to point in the direction that that object is feeling the force. Okay? So, when I draw a force diagram, I start with my dot, and then I always take care of my non-contact force. So what's the non-contact force acting on that teal folder? What's the force that's pulling or pushing on it that's not touching it? Earth. Earth is a non-contact force. If you're not going to remember that, write it down. Earth is a non-contact force. Earth is a non-contact force. So which way is Earth pulling or pushing on that teal folder?
Down.
Down. Earth is pulling down on that folder. Do you all agree with that?
Yeah.
Yeah, so I'm going to draw an arrow. I'm going to start at my dot, and I'm going to draw an arrow down. How long should that arrow be? very down?
Wow,
Yeah, because it's touching it.
wait, wouldn't it be like small since it's pretty much almost on the ground?
Like that?
No.
Yeah, so, I don't know. I'm just shooting in the dark here.
Yeah.
I don't know.
I kinda set you guys up for that. We don't know yet.
I was gonna say, does it not matter?
Does it not matter? I don't know.
Oh, I forgot you couldn't answer the questions like that. I was like,
I really don't know. They couldn't find anybody else to teach this class.
So that's why you're here.
Exactly.
That explains why.
It does, doesn't it?
out of all the people.
Yeah. Okay, so I drew my arrow down. Now I've gotta label it, because we could have a whole bunch of arrows here, we gotta label our arrows. So here's how we're gonna label. We're gonna use something called agent object notation. Ugh. I'm gonna put a big F.
Oh, I already failed.
It doesn't stand for fun, although fun, right?
I see that a lot.
We have that big F because it's a force.
Wait, that's just
Guys. So we have that big F because it's gonna tell us that that's a force. Now we have to label what kind of force it is. So our agent object notation, we are going to label this as Earth, because that is what's causing the force on, what's it acting on? The folder. I'm gonna put T for teal folder.
What'd you say
Agent object notation? Yeah. So the agent object notation here is Earth is the agent, that's what's causing the force. And the teal folder is the object, because that's what's feeling the force. Yes.
Wait, so since that's a contact force, then that folder on top of it's a contact force, right?
This is a non-contact force,
Non-contact.
right? Because the Earth is pulling on it without
Yeah.
touching it. But that's the only non-contact force we're gonna have. So Gage asked about contact forces. Gage, can you give us one contact force, one thing that's touching it?
Folder on top of the dude.
The folder, this one right here?
Yeah.
So we're gonna call this the rainbow folder, okay? Is the rainbow folder pushing or pulling on the teal folder?
Pushing
Pushing? Okay. Is it pushing up, down, left, or right?
down.
Down. It's pushing down on that teal folder. So, wait, I got an arrow down already.
Yeah.
But it's on top.
So just like add another point, I guess?
But we can't point at the
Can you
dots.
like branch off of that arrow? Or just like,
So, this conversation over here, I think sometimes they're a little hard to hear, because they talk softly. But Gage said we could put an arrow on top, and then he said, wait, we can't do that. Why can't we do that, Gage?
Because you can't have an arrow pointing at.
Yeah, all of our arrows have to point away from the dot. So we can't have one on top. But, Gage, what did you say?
can you branch off the arrow that's already there?
That's exactly what we're gonna do. I'm gonna put my second arrow from the tip of the first. Just like that,
I see.
okay? And then we have to label it. So we're gonna put a big F because it's a force. And then what is causing the force?
Folder.
The folder, we'll call it the rainbow folder. I'll put RB for rainbow. So RB folder on, and what is it acting on?
teal folder.
Teal folder, so T folder. Okay, how do we feel about that? Okay?
Yeah.
All right.
Oh.
Is there anything else touching that teal folder?
Yeah.
Oh,
the
it
one
does.
below it.
The one below it?
Yeah.
So there are two below it.
Oh, yeah.
Oh yeah,
I
letters
can't
in
really
dark
see.
blue.
So, letters folder?
Yeah.
All right, is a letter folder pushing up or down, or left or right?
Up.
Up. So can I go ahead and put my arrow up?
Yeah.
Okay. So I'm gonna go up. And we're gonna label that a capital F because it's a force.
Oh Lord.
What is causing the force?
Letter.
Letter four.
Letter folder. I'm gonna put a person L there. And what is feeling the force?
T4.
Teal folder. Okay,
So now that there's a folder underneath that letter folder, will we branch it off of the original line or something?
we can, yes. But remember, our contact forces are forces that are touching our object of interest. Is there anything else touching that teal folder?
No.
We're done.
That's it?
That's it. You said that's it. And what I heard you say is, well, that wasn't very difficult. Is that what you were saying?
Pretty much.
Yeah, good. So that's it. That's a force diagram. How do we feel about that?
Good.
Confident?
Good?
Okay.
Like you need some practice?
No.
No. I think
Oh, so I can give you a test tomorrow?
maybe.
No. Right, no,
I could like pass with a D, but like, oh,
I could probably come up with some pretty tricky ones.
I think we do okay.
Side or
I
something.
feel like there's each form stacked on each.
Yeah, I'm pretty crafty that way. I am.
We'll
Okay,
need to
so-
shoe in the grass.
In all honesty, force diagrams are pretty straightforward, and they are a very important tool that we can use and we will use throughout the year. So it's really important, that's why we do this as our first unit, because it's really important that we understand force as well, because forces impact motion. So if we know something about the forces, then that's gonna tell us later on something about the motion. Okay? So now, I'm feeling another lab coming on.
Wait, a lab?
Yeah,
Like now?
yeah.
Yeah.
Well, no, I mean like tomorrow.
Oh, okay. Yeah.
Because I'm curious about how long those arrows should be. So I feel like tonight I'm gonna think up a way that we can do a lab to determine how long those arrows should be, or it doesn't even matter.
Wait, can't we just like use the length as the amount of force?
You wanna use the length as the amount of force. How do you guys feel about that? So like a really long arrow means big force,
Yeah.
and a really short arrow means, so how do we know how much is a big force and how much is a little force? Guesstimate?
Why not?
Yeah. Like say I put this on there, so like that would be a tiny arrow, but if I put this on there, it'd be a bigger arrow.
I like where you're going with
Like,
that, and now
by the weight.
I feel like I have an idea for a lab tomorrow.
Okay.
Alright,
Thank you.
you got it.
All right?
You better write it down.
I am. I'm gonna write it down right now because you know how my memory is.
You couldn't write down that one of the slips that